All right, this is try number 3, a discussion about levelized cost of electricity, and why it's so important. I have a couple of slides I'm going to show you. I'm going to move right into the results then and show you the implications of some of the ideas I have, which might be all wrong. And then I'm going to go into some details of how to effectively set up scenario analysis and effectively make some financial models. Now I'm starting with this little thing that says, okay, there was 632 billion spent, and now we have to spend 90 trillion, and a whole bunch of it has to come from the private sector. Now, if we're going to have this much money spent, we better kind of get it right and understand the costs of different technologies. I have been making the point again and again that the type of investments that are made to combat climate change, by definition, don't use carbon. Come on. They don't use carbon. And if you don't use carbon, then you're going to have less fuel expense. But on the other side, you're going to have more capital, whether it's a solar project, a wind project, an electric car, a energy efficient house, a nuclear power plant, a geothermal power plant. Every single one, you have more capital and less fuel. Okay, let's go. Come on, go to the next slide. Okay, now the other thing I'm going to do is discuss this Lazard study. This Lazard study is interesting for me because it seems to have a lot of people who refer to it and are interested in it, and we'll show you they have these nice football field diagrams. For instance, the cost of solar is supposed to be 2.4 cents. This is US dollars per megawatt hour. I hope I put the there it is. US dollars per megawatt hour, and here's this cost, and then the cost of a combined cycle is, it's more, and so solar is better than gas. The worst thing you could do here is make nuclear. It's very, very expensive, and there's a wide range, and all the data from this is presented in a little table at the bottom of the sheet. Now, I'm going to show you. I hope I'm not going to be a jerk about any of this and start criticizing things too much. But my suggestion is instead, we can make a lot of pretty graphs, but it's a whole lot more important to understand where the numbers come from, how they're computed, and be able to make the computations themselves. Again, it's kind of a theme. Pressing a button and getting some magic answer doesn't mean anything. Let's figure out how this stuff works. And if you look down in their website, I suppose, perhaps I won't. You go to Lazard and you find hundreds, not hundreds, but whatever, 20, 30 beautiful graphs, and you finally find this little spreadsheet. And in this little spreadsheet, they show you that they're basically making a goal seek to hit a IRR, equity IRR of 12%, but in order to do that, they're making an O&M escalation of 2.25%, but no escalation on the price itself. They're using a debt-to-capital ratio of 60%, which for people involved in project finance, that's not very much for a solar project, for example. The cost of debt is an enormous amount, especially relative to the inflation rate. 8%. Now, you can argue that they don't even have any. This 12% can be related to kind of the inflation rate. It's an enormous cost of capital. And what we're doing is we're estimating costs. We're not estimating what you have to normally do, which is, let's optimize an IRR. Let's get as high an IRR as possible. I want to look at the cost of capital, not not just optimizing the return. We want to understand the true cost of the investments. I hope I've done that okay. And then they have 40% tax rate, which I really don't understand. They have left this alone, even though the federal tax rate in the U.S. is 21%. And then they have a economic life. And they use wind here because wind is nice. It's got they have a 12 months construction period, so they can do everything annually. They don't have to worry about degradation. So we understand why they would pick this one as an example. And they don't have any. They can put in some of these U.S. tax features, but we're going to leave those out and focus on the kind of the cost. We can put in some different tax depreciation and understand how much the tax shield is. So that's what we're going to work through. I've got another one. If you go to the website or whatever, my little resource thing, and you go to chapter 5 and then folder conventional, and then chapter 10, I've got a whole bunch of their old studies here, and that's this one. Wind is 25 US dollars, and is that the one they're using that case here? So that's why I put that there. This is Ms. Jennifer Grandholm. I saw her on television. She is the U.S. Secretary of Energy, some very big job. She used to be the governor of a state of Michigan. And the reason I put her picture there is because I saw her on television once talking about the Lazard study and referring to this and having it proved that solar was cheaper than whatever. I don't know if she said gas or coal or something like that. So that's what I just want to emphasizes. This study is used a lot, and let's understand how we can exactly replicate that study. I have to put a picture of my friend here. I feel a little guilty. This is John Boudreau. He's unfortunately no longer with us, but we had so many discussions about the costs of different alternatives. We used to go and make these hour-by-hour dispatch models. I just have to give a little respect to him. He's just wonderful. Compared to these other people, he was wonderful. We used to go to this bar we used to work on computers and putting Excel into an hour-by-hour model and spend hours. And when we spent hours, we'd talk about the cost of different alternatives, and we thought, John, I remember he thought, what are you talking about, solar? Are you crazy? And then he'd kind of get into whether gas or nuclear is better. Now, when we discussed these things, he was an engineer, but he understood economics. Solar, I'm going to talk in this slide about the difference between efficiency, which often, and this is why I'm mentioning this here, because when you talk about levelized cost of electricity, and you see engineers talking about hydrogen, in the old days, solar power, electric vehicles versus hydrogen vehicles versus internal combustion, or any of these things, the engineers love to talk about efficiency. That's what, they've learned. And here is this slide. You used to see this slide, and thankfully people don't waste their time on it anymore. But in the old days, especially for some of you young people, if you're kind of starting on solar, you haven't seen this, hopefully. But this was this great slide. Everybody put this in their presentation, and it was supposed to show how the efficiency of solar improved. And that's one of the most it's not completely irrelevant, okay? but it measures how much sunlight there is coming in compared to how much electricity is going out. Now, the price of panels is not based on the sunlight coming in. It's based on the electricity going out. So if you have a lower efficiency panel, you'll pay less and get the same cost per output. Now, you have to make bigger areas, so there's an area, and maybe if you make a bigger area, you have to spend some more O&M because you have to walk around it a little more or something like that. So there is some importance. But then another lady said, what's this difference between capacity factor on the one hand and efficiency on the other? And I kind of looked at it and I go, oh gosh, what am I going to do here? It turned out to be a really good question. Capacity factor is driven by how much sunlight you have at different points in time. So in other videos, I've gone through and simulated the capacity factor, which depends on where you are, basically, and how many clouds there are, and what the sunlight is in the summer and the winter time. This is this is in Oman, okay, and it depends on the weather. This is the temperature, and this is the sunlight. And then the other thing, if we go back to John, you know what? When we were talking about the solar power, it was way before here. You know, it was before here. These are the tariffs set by Germany, 450, and I will keep repeating this slide over and over again. When the price of electricity was about 70. 450 versus 70 at the high, and then this blue one is the price of electricity at the low. You see how it depends on natural gas. Everything depends on natural gas. And natural gas varied here, and we'll look at natural gas in a minute. And different places have different capacity factors. Here's Paris and Nigeria, I think. And one more thing just before we get started, I hope, I don't need to. Let's go through one or two more. This is this question I always ask, and that now finally people, I hope, are getting this right, which is more capital intensive. Well, this is much more capital intensive. Capital intensive measures the amount of capital you have relative to the amount of the total cost. This is all capital, basically. I don't know how much operation and maintenance cost. This looks like it's all capital intensive, a refinery, but oh my gosh, you have to spend all that money on the raw material, the product, the stuff that produces CO2 in the atmosphere. So this is much more capital intensive. Capital intensity also depends on how much life you have. You could say advertising is an investment, but that advertisement, you hope to get it back right away, or maybe whatever, with a little lag. When you have to spend money on a nuclear plant and wait 65 years, perhaps, or something like that, to get your money back, that's a whole lot different than an investment with a short life. So we have to account for the lives. These people who say silicon is not there, we also... This just goes through the cost, and it's obviously on the website. You find on the website. You just download this stuff. It gets it from this website called PV Insight, and the cost of solar as of making this one has had this dramatic decline, and it's driven by polysilicon, and there doesn't seem to be a dramatic shortage of sand in the world. So the other thing I just want to kind of make a point on is that, okay, there are very interesting arguments about the policies of renewables and whether they can really work or not, but we want to look at the cost. Okay, so that's a little bit of introduction. Now, what I'm going to do, now when I made these videos initially, I thought, okay, this is easy. Let's just go and take the Lazard numbers. Now, again, I was going to go to their website. I just decided not to. Here's the little thing they've put for a couple of other years, demonstrating kind of how the costs work. And we want to basically match and be able to put their assumptions in and get their LCOE out. they put taxes in. So I made a little data book. We can call it a data book. It can be a mess. You put the source of the data in. I've just had some discussions with other people on fascinating other kind of projects and what seaweed, making oil out of seaweed or some stuff like that. But, you've got to document every kind of assumption. So all I did here, this is representative of a data book. I put the different data in, and then we're going to talk about this a lot more once. So this has got data on all the kind of projects, and you just need any project. I'm repeating myself from other videos, but any project has CapEx, OpEx, some kind of physical production, and then we get the cost by relating the CapEx plus OpEx to those physical production and see what kind of price we have to charge to get there. And the amount of capital recovery on the CapEx is a really big deal. So we've got all these basic operating drivers. And then I didn't finish my sentence just before, and I'm sorry about that. I don't know if that's a sign of senility here. But we put these operating assumptions, and I took a couple of different years, 2023 and 2020. Interestingly, they didn't, even though there have been dramatic changes in cost of capital, maybe at least nominal cost of capital from differences in inflation, Lazard did not change those assumptions. So we put all of these in, and we use a little index function to grab it, and then we can pick a different technology and find different costs. Now that's operating. Again, one of my own, I think my only real hero in terms of an academic in finance, and I'm serious about this, is a man who I've shaken the hand of, Mr. Merton Miller, long gone, Nobel Prize in 58, I think, who said, financing is irrelevant. That's the way people interpret him. But the brilliant thing is we think financing and project finance is incredibly important. But the idea of splitting financing from operating assumptions is, for me, just look at how brilliant that was. And we mixed them all up the way people used to do this, and unfortunately they still do. They will put an input page and have one input page for operating and financing, and they'll put that in the same page. Oh my gosh! Because what we want to do is take these different projects and see how things work. Now, I started with a case with no taxes and no debt, started adding inflation just to the O&M, not the capital, put some taxes in, but then took the taxes out, put some debt in, put some, left the debt in and put the taxes in, and then we did some project finance debt versus classic debt where you keep the debt to capital at the same level on the balance sheet and can use a weighted average cost of capital. With project finance, you don't really do that. And then I put some sculpting in because of the cash flow effects of inflation and taxes. And then we get to this Lazard case, which had the 40% tax rate, the 60%, and all of that. And we see if we can match that tax rate. And then we start adjusting the Lazard assumptions, put some more realistic tax things in, put what I think is I get emotional about this one, but if put a credit spread of about 1.5% in, a little bit of a real interest rate, although that hasn't been observed, And we get about a 4.5% interest rate consistent with the inflation rate. And then we put a more realistic debt ratio in, which is what project finance is all about. And then I think I might have shown you this. Where did I? Yes, I didn't show this slide. This is the levelized cost from my friend gave me this, okay, and from Pakistan. I couldn't afford it. He did. They gave me some levelized costs, which are actually a lot higher than others, and put in different rates. But what was interesting here, they didn't really say if this was the return on equity or the cost of equity. I think it's probably the return on equity. And they showed in Germany, people are willing to accept 5% at that time. It's gone up since then. And in the US, you need 8.5%. Well, whatever, you want more. That doesn't mean the cost of capital is different. UK, kind of, you can see how it's kind of gone down, and even in China it's kind of gone down. Japan very low. So my argument is that the true cost of equity capital is not, it's okay, a little higher than debt, although you could even argue about that, but I put a 6% in. Okay, maybe that's too aggressive, but the whole point is you can go and change these assumptions. Now, when we change these assumptions, we make a little project finance model. I show you that for about 50% of the cases, until we get to project finance debt, you don't even have to do this. But basically, it's the same sort of thing as Lazard, except at the very end, you prove that the equity IRR is working. And let's go back to our case up here. How about this one? Okay, this is this case, and you prove with a financial model that you're getting the right IRR when you put the LCOE, when you put this price in, you're getting the right price, and you even make a balance sheet and a income statement, and that's what I'm going to go through. I'll make this part 2. I'm going to make part 1 and part 2 of this video, I think. Okay, because otherwise it'll just get too long. And here's what I really wanted to do now. Originally, when I started thinking about this video, I said, oh, no, I didn't finish this. Oh, shit, that's okay. Let's look at the different scenarios. And which one should I start with? I can start with, let's look at a wind case, okay? And if we look at a wind case, we can run all of the different assumptions about cost of capital in a wind case. And in the next video, I'm going to show you how to do that and why a macro is so important. Now, let's make another macro. I'm sorry, I'm going to make a really simple one, but okay, I'll just call it macro 3. Let's adjust the axis and reset the maximum. Okay, and close this and switch our macro off. I hope that still works. And I'm gonna just assign this little macro to this one. Okay, so this one shows you that when we this graph, and I'm going to show you how to make this graph in the next slide, and I suppose I have to. I'm going to leave it there. I was worried about this little thing being cut off. Okay, we can show you this. If we look at the Lazard case, I believe this Lazard case, this 25.45, okay, it's not exact to the penny, and I'll discuss why perhaps a little bit, but not too much. Oh, here it is. It's this 24.4 right here. Okay, sorry about that if you start yelling at me about that. Well, good. Okay, because at first I got all obsessed about wanting to hit it exactly. Okay, if we had no taxes and no debt, and we were just aiming at Lazard's 12% IR, we'd get this. If we include this was with no inflation on the O&M. If we include inflation on the O&M, we get this. If we include, now I'm thinking, by the way, I might have to have three parts to this. If we include taxes, it goes up, but then we put debt financing in, and it plops right down, and then we put some. Just a minute. We put some tax. This has no taxes. This had taxes and debt. Doesn't make the taxes because we had a fast depreciation. Didn't make much of a difference. And then we start moving to, instead of classic debt where we keep the debt to capital ratio the same on the balance sheet each and every year in project finance, we don't even look at a balance sheet for the debt. Instead, we use some kind of sculpting or level debt repayments, and then we get this number, and eventually we put in the this one. When I sculpted that, I guess I got a little bit of a higher number, and that's kind of interesting. I'll show you why exactly, go through some of the technical details. But that's our Lazard case. Now we put, in this case, we put a lower tax rate in. We actually get a higher number because we have that really fast tax shield. And then we put the lower interest rate in, the higher debt ratio, the lower equity cost, and then we do something really really, really important. Now, this last thing I've got to adjust, okay? I'm going, let's put the expected life here instead of 20 years. I think people are using 30 or 35 years. That's what I hear for wind. And now I'm going to have to rerun it, okay? And we go through all of those scenarios. Now, what I'm hoping you say is, ooh, let me get a little more advanced. Let me understand, okay, I'm going to, of course, put this, I'm going to put this, no, we'll start a new session. I'm going to, why does it say sponsored like that? I don't have any sponsors. I don't get any money at all for any of this. Why, if I go to the Excel and VBA, we've got this energy analysis, excuse me, and I go to the levelized cost of electricity. I'm going to put this file here and here and here. I'm going to kind of put it in a bunch of places so you can find it easily. And maybe I should have said that right at the beginning, because people kind of complain about that. Not complain, but ask me politely sometimes. Okay? So here, now I'm going to rerun all these scenarios. I think I just did that. Excuse me for doing that. But the key thing is it shows you that if we look at real costs, and this is kind of, in a way, remarkable, that means the cost today. That means levelized cost. If I want to compare, for example, this cost with the cost of natural gas, which would be the right way to do it, and I believe if we look at this number now, you can see that we're going to use conditional formatting. If we could possibly get a wind farm with a 55% capacity factor, completely unrealistic, for example, in Germany, I think we might have 25 or something, okay? In fact, let's just show you that so we can put our own assumptions, and this cost might be pretty low and what have you. Then that we could get down to this really low real cost. But now if I just change some of these scenarios and run that, then we have a kind of, this is the cost if you want, well, let's stop here. Let's go up here. I can't see this exactly. Okay, what would this be? We can see this scenario. If we put a lower equity cost, so if we start at this Lazard case and then go down to a which would be 55, that's if we have to have a flat price. If we put our lower cost of capital in and allow our price to escalate, then this is the price. And you know, I've got to check something here, okay? This had a 5-year tax life, which is a very, which is suggesting that the taxes are actually a benefit. If I put a 20-year tax life in, let's run the scenarios again. I just did something completely dangerous, by the way. Okay, that makes a little more sense. So then the lower tax rate now is helping us, and the ultimate cost is 27. I think that wasn't so bad. All right, I almost want to leave that in because it kind of is a little bit reflection, but I'm not going to, because I'm going to get myself messed up. So I'm going to put that back. Let's put this back to our 5-year tax life, and these are our drivers. We can put our 55% in, and I would argue strenuously, emotionally, without getting mad at Lazard or anything like that, but I would argue that this number is the number we should use to compare, for example, we can do this to compare this to natural gas prices, okay? Let's do, and what we have, it's kind of interesting. If we start with this one, did I run this? I ran the scenarios, right? If we start this one, it's kind of dramatic. This 25, this number is half of this number. These things, with respect to the cost of capital, mean a whole lot. Again, I was going to do this thing because I think this is so important to be able to, instead of just pressing buttons, going to the Lazard website and saying, here it is, I think it's so much more important to be able to get the word out, to be able to put these in yourself, exactly like what I was showing you. Now, this is my real theme. This is the theme for my book I'm trying to write, my next book, and everything else. I would like to show you that now let's talk about a nuclear plant. You can be pro or anti-nuclear. I noticed that the world changed a little bit with respect to this. I hope I'm agnostic. Anything we can do that's going to work, we should do. That's what I think. There's a man named Simon Clark who I love his kind of videos. He seems, let's do this. The only thing he doesn't like is that carbon capture, and nobody likes putting those little aerosol things in the atmosphere. But other than that, he's like, solar, nuclear, whatever, conservation. Please don't go to a football game on an airplane, or go on a golf outing and take a big airplane just to go on a golf outing. Don't do things like that. And don't ever do a tear down house. Don't go to Antarctica. I know somebody who did this on a cruise, and take a business class seat to go on that. Oh my God. Okay, that was a little off track, but let's now run our nuclear. And I'm going to use this one because I happen to work a little bit on nuclear. Well, it's just I shouldn't have said that, maybe. And this nuclear best case is not a very best case. It's got a cost, and when Lazard does this, and you need to read kind of the footnotes, this includes the interest during construction, and it should include an equity, we used to call it equity allowance for funds used during construction. It has to include all the true financing costs during construction, and it does, and it's got a 90% capacity. But this investment cost is very high, well, it's high. It's higher than what I've seen. And then you've got a very big O&M cost. Now, with this high O&M cost, by the way, I'm going to put the 40 back here. I should have redone this. Whoops. Hang on. Okay, I should have redone this. The Lazard had 40 years, not 65 years, and so we'll adjust the lifetime the way we did, and then there's if you spend this much amount, which is an enormous amount, on O&M, you're gonna imagine you take. I've got. My car, I've just got a newer car, I guess. I try not to drive, but it's a 2006 car, I think. 5? Something like that. And I had to spend a bunch on maintenance to keep it going, because I think the best thing to do for the climate is not to buy a bunch of new steel all the time and put whatever. To use old stuff is probably the best. Maybe I'm getting you mad about saying that. Why'd you need? So if you spend a lot of money on maintenance, you're going to keep the thing going. If you don't spend a lot of maintenance, it's going to have a shorter life, okay? And then they gave you a heat rate, this fuel expense. Okay, that nuclear fuel has been changing, and they don't really have it in there. And Lazard gives you a cost of electricity of 12.9 cents. 12.9 cents. That's what they give you. Now, if we would go here and put our Lazard case in, now this is what we have to do here, and in the next video I'm going to show you how this works. In this Lazard case, it works with a goal seek. So you kind of have to press a little goal seek button, and you can look at this. So you can get the file and look at this, or you can watch the next video and I'll explain some of this, but I'm not going to spend hours going through everything. And I have a little test to make sure that the balance sheet balances and the IR works. And, okay, when we do our own case, this Lazard LCOE should be this one. Excuse me for this, okay? Okay, I've been going around and around on this stuff, but it's pretty close. It's pretty close, okay? Now, if we work through some other cases on this one, let's say we lower the interest rate. And this one, when you change this little drop-down box, by the way, it's running the macro, then we're starting to get a little lower cost. If we put a debt ratio in, then it's starting to have a bigger dent. If we put a lower equity cost, it's got another dent. If we use real cost instead of nominal cost, it's the same kind of thing, but I don't know why that one. And then the key one is this last one, which is you correctly reflect inflation. So look at this difference when we have a capital-intensive, long-lived asset that we make long-lived by spending money on it and keeping it going. That difference is enormous. So we could argue about all these operating assumptions and all that, but these mechanical things really matter. Now, you can not agree with me on the assumptions, although remember, we're not talking about what you want when we're talking about the cost of equity capital. What you want is another thing. And people want more money and they want to make monopoly profits. They want to do all this thing to get more money. Fine, whatever. But I'm talking about the true cost of capital. And if you really think about the policies, if people start wanting too high return over a very, very long time, that starts to compound incredibly. And then eventually the government's probably going to come in and have to build these things anyway, or finance these things one way, indirectly or directly. Okay, and so now if we do run all of the scenarios, what we're doing now is just running them all. And now you've got this really dramatic difference, and you can put your own assumptions in, but my theme over and over again is how important these kind of things are to measuring the costs. And I showed you with my friend John, who, this is my kind of way to remember John. It was so wonderful drinking. Oh, he had so much beer. I couldn't drink it like that anymore. He was wonderful. See, I cannot. But these are so important, just as important, maybe more important than the operating assumptions. Now let's do one more case. Okay, let's do one more case, and let's compare let's do a NGCC best case. Now the NGCC best case, if we do this, okay, again, it switches the key code number, and when we switch the key code number, we have a little conditional formatting that says what case we're on, and it pulls this case over here. And they gave a 90% capacity factor, which, again, this kind of proves that, well, you can run this is like pressing a pedal down on your Ferrari. You can run it as fast or as slow as you want. It's not like a solar plant where somebody upstairs, up above, says how much it's going to work. Okay, let's not get further into that question. And then they have a low investment cost, okay, because and that's probably realistic, from what I understand, is because there's not too much demand for these things. And if we look at GE's stock price, you can kind of see it. They have some fixed and variable operation and maintenance expense. And then they have the big question, which is the gas price. Now, they used a 3.45 gas price. I just looked at this. Maybe I'll look at this. Okay, I'm a lot of this stuff, I'm sorry if I'm redoing it again and again, but if you go and you have to go to the on the website, the page called databases, I think, okay, and this shows you, look at the U.S. gas price. The U.S. gas price as of, because I think we've had a warm winter from, everybody else says, oh, I love this warm weather in the winter and where I live. Oh, my gosh, I love it. I'm like, oh, it's global warming. Okay, who cares? I'm such a pessimist. I'm so depressed all the time. The gas price is only 1.72. Oh, my gosh. But if we change this, and it's wonderful, this you can work through this file and see, all you do is download this from a World Bank website. If we go to Europe, then again, all I try to do is take that data and make it flexible, make some nice kind of, is it normally distributed and all that stuff. It's not, because of all this crap here. But now in gas price, the very last gas price in Europe was 8.15, and if we go to Asia, and I think this is a good way to kind of get an idea. It's 14. So what we use as the gas price is a big deal. And if I go back here, okay, I'm closing that file. And where am I? Okay. I'm thinking about the next video as I'm doing it instead of keeping a train of thought properly. Okay, so this gas price, I said we could put higher or lower, and how about let's use 5 as our gas price, okay? Now, when we use 5 as our gas price, of course, we won't be matching it to our Lazard case anymore, okay? I should have made this so it goes faster. Maybe I'll stop it. Oh, come on. Each time it's rerunning the macro. Okay. How's this? I'm going to stop when it stops. Okay? Come on. Okay. 4.38. That's the number. Okay. It's probably 4.375. Okay? And now we take our best case, and now we run the scenarios for our best case, and I hope you're not surprised by the answer here. And I hope you're not surprised by the fact, oops, I have to change one thing. I have to change this back to 20 years. You could even argue, gas might be obsolete. If you're going to build a gas plant, you should have a stranded investment risk. Okay, I've got to run all the scenarios, but it's no big deal. And all the running scenarios do this. They change the little 1, 2, 3, 4, 5, 6, 7 scenario number that you used with the index function. And then you've got a kind of a big change in going, these cost of capital had no change. This had a little bit of an effect. Okay, but, and in fact, that's a bigger effect than I would think it would have, because this is all related to the capital cost. But just I'm going to pause one second here. I made a little change in the inflation rate assumption. That's why it was a bigger effect than real. So this is the effect. This 47 versus 36. Okay, there's some effect of this inflation kind of assumption. But again, now, how about this? I'm going to do this, arrange this format of the axis. I should have probably just made a macro, so we could have made it all automatic. Let's make this 150 or something so we can compare the nuclear plant to ours. So this is kind of, if we keep the same scale, that's where it is. Oh, the natural gas is still lower. Of course, that depends on the natural gas price. If the natural gas price gets to be 5 or 6 or 7, and if we include some emission cost, which I really should have done, sorry about not including those. I think I need a whole nother video on particularly the cost of natural gas, and especially this big issue and this gigantic unknown, which is the cost of leaking methane. And if we use LNG, kind of the losses we get in between, okay, not being too negative about natural gas, but kind of I am, sorry about that. And then if we compare that to our, we're going to compare that to our nuclear best case, again, and rerun the scenarios, so I don't have that kind of distortion for inflation that I just did. Then you can just see how much more dramatic, dramatic that change was. And I'm going to pause this one more time. Okay, I had forgotten to change the extended life. Okay, I hope. Here's what I'm hoping you're saying. Well, probably you're not. You're saying, "Oh, I'm sick of this. Get me off. Get him away from me." Well, I'm hoping you, just to summarize, I'm hoping you see through the dramatic effect of these assumptions on these cost of capital assumptions on capital intensive investments. And the policy questions that they raise. And I'm also hoping you say, let me get into the Excel. Let me download this file. Let me understand why these macros work. I'm going to show you just one other thing. If we here, we also made a, okay, I'm going to put this as a Lazard, this as replication. So up here, we have all of our different scenarios. And then if I go to this time, I'm just going to go to the Lazard case. And what happens here is I made a little thing, and we're going to, in the next videos, we're going to go through all of this, how we can compute the LCOE, how you can compute that without a financial model, with a financial model, when you need the goal seek, when you not need the goal seek. If I press this little button that says copy all, you see how it's going step by step by step, and it's copying every single scenario. I mean, but when it's moving from scenario to scenario, it's doing the goal seek, and you can see that these numbers are reasonably close. I think they're very close, okay? So okay, if you want to the last penny, this Lazard, they made some funny kind of assumptions that I couldn't even get, okay, with their half-year assumptions, but more important, how they were computing the level payment on the debt. I just couldn't work it out. And then we have a little comparison, and so this time when we compare the costs, okay, there are these little differences, but essentially we're getting just about the same answers all the way from a nuclear plant to a different type of plant. So at least we have a model, and somebody says, oh, take that Lazard. I want to understand what's that Lazard case. We have that, and then you can put different assumptions in yourself and get it. Now, if you then want to say, no, I don't want to take this Lazard case, I want to take this last case here, okay, and I'm going to go on the nuclear plant and kind of cheat on the nuclear plant and put this to 65, okay, so we put the higher costs in here, and then I'm just going to, this time, run the whole thing again. Again, it's going from scenario to scenario, and here's another thing I kind of came up with in this kind of analysis. If you want to really work on scenarios, learning a couple of simple, this VBA stuff that goes through scenario by scenario is very simple, really. Now, so now we have this kind of thing where we compare the different, here's the Lazard cost versus our cost, and if we see the last kind of ones, these are the differences between an NGCC plant, and this is the difference between a nuclear plant. And I hope this is another way to kind of illustrate these things. And illustrating this stuff is really important. Let's go back to Lazard. You know, they make all of these waterfall, there's John again. They make all these waterfall charts, but can you see if you can do this yourself? If you can do this yourself, prop in your own costs, start changing some things, and then really evaluate this in very, very important cost of capital. I think that's a big deal. Oh yes, I'm going to